Welcome to the chemistry department. I'm going to give you a quick tour of some of the really cool instruments that we use in our research program. But first, this is Steitz Science Hall, named after the recipient of a wonderful, wonderful award, a Bachelor of Arts in Chemistry in 1962. He later went on to win the Nobel Prize. Go team. Anyway, he did some amazing work with ribosome chemistry and in 2009 got the Nobel, and he's been really great. Sadly, he passed away a few years ago, but he says that one of the most inspiring things was working with his faculty here at Lawrence, and we hope that you will choose to do the same thing. So I'm going down the stairs into the basement. Now, the basement is a really cool place because it houses some of our research labs, as well as one of our most favorite instruments, our nuclear magnetic resonance instrument, known as the NMR. So, what does the NMR do? Well, when you make a molecule, I know, it sounds weird, right, to make a molecule, but you synthesize a molecule from others. So you have starting reagents, you do a synthesis, so you rearrange those molecules in a certain way, and you create a new molecule. The kicker is, how do you know you made what you sought out to make? Imagine you're making cookies, and you mix all the cookie ingredients together, and you put them in the oven, and you wait your time, and oh, the delicious cookies, you can smell them, it's so exciting. You open the oven, and instead of cookies, you made a cake. Well, that's weird. You put all the ingredients together, and you should have gotten cookies, but instead you got a cake. So chemistry is kind of the same way in terms of synthesis. Molecules are so small that you might not make what you sought out to make. So how can you tell if you actually made the molecules that you were trying to make? In come the NMR. So this is an instrument much like MRI, magnetic resonance imaging. I'll move this way so you can see it. It's kind of loud, so hopefully you can still hear me. So this instrument, what it does is it determines the kinds of atoms around the various molecules that you would make. So you can determine if the proton or the hydrogen atom is connected to one carbon and or connected to an oxygen, or if there's a few other extra hydrogens connected to a carbon. So you can determine the different types of structure of your molecule. Its nickname is Little Jerry. It's a fantastic instrument. You would typically use it in the sophomore year in our organic chemistry 1 and 2 labs. And then you would use it if you were to do synthesis experiments with Graham Sazama in inorganic chemistry or Stefan Nevert in organic chemistry. So the next cool thing is my research lab. Ta-da! Here we go. So I like to ask the question, how do molecules move in liquids? I answer that question by this snazzy thing. This measures viscosity and density of various liquids. Another cool thing that I like to ask is what sort of materials are used in artistic objects. Let's say you have a 14th century illuminated manuscript. So this would be a religious text from medieval Europe. What kind of compounds are used in making the inks and pigments? I can shoot it with lasers with this thing. It's called Raman spectroscopy. And I can basically talk to those molecules and say, who are you? And they will hopefully wave back with their molecular vibrations. Cool. So now I'm gonna go up the stairs, and I'm gonna pause it so I don't have to take you up the stairs with me. I'm now on the first floor of Steitz Science Hall, and I have with me Artemis. Isn't that cool? This is the atmospheric research trailer for engagement and measurements systems. I always butcher the name, I'm so sorry. Our faculty member, Deanna Donahue, she's an atmospheric and oceanic chemist, and she asks questions of what sort of compounds and reactions occur in the atmosphere and how do those affect big questions like global climate change. And so she takes Artemis, so I'll get a picture. So this is a solar panel that she hooks her instruments up to, and so she'll take it to various places around not only here, but she's taken it into the Dakotas to measure different ozone concentrations due to the fracking industry and various other atmospheric questions. But she takes students with her on these huge field campaigns, and she's always looking for bright young minds to go into these crazy adventures with her. So that's some of the types of environmental-based questions that we ask here. Oh, and we've got Kelly. This is Kelly. She's working on some really cool stuff with Graham Sazama, making really neat molecules. Go team! Hi. I'm now on the second floor of the chemistry department. And this is where a lot of the organic synthesis and inorganic synthesis occur. So Kelly, who you just met, would be up here working in synthesizing different molecules. Ta-da! So this is our organic chemistry and inorganic chemistry teaching laboratory. This is where in your sophomore year you would learn how to make these different types of molecules via these various procedures, and then you would test them in the NMR downstairs to see if you actually made what you thought you made. And we have other instruments that you can use, like, ta-da, these instruments. This is Fourier transform infrared spectroscopy, also known as FTIR. It measures molecular vibrations, so it can tell you a lot about the different compounds. We also do some really cool inert atmosphere stuff. And so this would be a nitrogen-based atmosphere. Let's say the molecules that you're using are very sensitive to water. You don't want to have them exposed to the atmosphere. And so you would do your experiments in what we call a glove box to make sure that they're not exposed to water. Okay, let's see what else we can find. There's always so many things you can find in this place. In front of me we have the inorganic and organic chemistry research labs. Ta-da! In here we've got also different types of hoods. These are going to catch the volatile compounds from your reactions. And I believe Kelly is working in the back hood. And we've got another glove box that you could use. Cool. So one of the things that we take very seriously is giving students space to do their science. So not only is chemistry important in the laboratory, it's also important in the library, which means you need some study space to read those research articles, to write up those papers, to create those presentations. So we try really hard to get all of our research students to have their own office space. And those office spaces are all connected to one of the various laboratories. So if we walk through, this is our biochemistry laboratory. So if you're interested in how do chemical reactions occur in the body and how do they affect the various mechanisms inside the human body or any other biological body, then biochemistry is for you. I'm now standing in one of the 2 office suites we have with our chemistry faculty. We have student space here. This is where students would meet and work on homework sets or work on laboratories together. We've got a chalkboard here, and your faculty are located, well, when it's not #COVID time, your faculty are here with their doors open because we are desperate and excited to help you in any way we can. So that kind of ends the tour. I'm now back at the top floor of our atrium. This is where I started. Ta-da! So this atrium is a place where students gather to study. We also have a lot of science parties. We have a trail mixer at the beginning of the term. Just really to get to know you, because one of the things that's really cool about working with students here is we get to know you personally. We get to hear your own scientific voice. Great. So I hope you enjoyed your tour. Go team!